As with any question in dynamics, the first step is to draw your free body diagram and label all the forces that are acting on the mass in question. So in this case, we've got Jamie sliding down on a sled down this ramp, and the forces that are acting on him are, of course, the force of gravity, which is always straight down towards the center of the Earth. And anytime you're on a surface, you get this squeeze between the surface and the object, which we call the normal force. It's always 90 degrees to the surface. So we've got one 90-degree angle right in here. So our normal force, 90 degrees to the surface. Now it says that there's basically no friction. We can ignore friction. So that's it. Those are the only forces that are acting on Jamie as he slides down the ramp. So that means if I want to determine my net force, since there's only two of them, it should be fairly easy. Net force is the sum of the forces. So I can do them in any order. I can go with my normal force, add it to the force of gravity, and I get my net force. And then once we know our net force, of course, we can then figure out our acceleration because F net is always ma. Now, it's always important to try if you can. Some questions are a little bit harder than others, but try if you can to determine which way the acceleration is going to be. And anytime you got a question that's confined to a surface like this, in this case the ramp, we know the acceleration. The acceleration is down the ramp in this direction. So there's the direction of your acceleration. Now that's not a force, but Newton's second law says that if you know which way the acceleration is, you automatically know which way the net force is. It's in the same direction. So let's draw our tip to tail diagram and add those two forces together. So I've got a normal force, kind of up at an angle like this. And then at the tip of the normal force, I'll put the tail of my force of gravity. My force of gravity is straight down. Now remember, we have to end that at the correct location, so I'm not going to put an arrowhead on it yet. But we know the direction of the net force is along the ramp. So I'm going to extend this force of gravity down so that my resultant, my answer, is at an angle that's parallel to the ramp. So this is what my picture looks like. There's FG. There's Fn, they're added tip to tail. When those two add together, they create a net force, which I'll put in blue, that points from start to finish. So my net force is like that down the ramp. So there's my triangle. Now we need an angle in there. So if we go back to the original sketch, we know this little angle down here at the bottom of the ramp is 25 degrees. And if you look at the geometry of it, I've got my force of gravity, which is straight down. So I've got a little 90-degree angle right here. So you can see there's a triangle on the inside, little right triangle. So if this is 25 degrees and this is 90 and the angles have to add up to 180, we know this angle right in there is 65 degrees, which means, going back to this one right here, if I extend my normal force line straight down, that little sliver right there will be back to 25 degrees again. So this little angle right in there, which I will shade, is 25 degrees. And remember, that's because the normal force makes 90 degrees to the ramp. So those two angles, the 65 and the 25, have to add to 90 degrees. So the angle between force of gravity and the normal force, this angle right in here is 25 degrees. And now we can go and finish our problem. Now we're trying to find F net. We don't know any masses or anything, but we know the formula for Fg. So I'm going to choose to use F net and Fg in this triangle. Don't forget we've got 90 degrees right here. Remember the ramp is F net and the normal force is 90 degrees to the ramp. So we've got a right triangle. F net is opposite to my angle. Fg is the hypotenuse. And opposite over hypotenuse is sine. So I can say sine of 25 degrees is opposite over hypotenuse. There's my starting point. And now we can go ahead and put in our equations. F net is always ma. Fg is always mg. Sine 25. Notice the masses cancel. which tells us something in physics. It tells us that no matter what the mass of this object is that's sliding down the ramp, it will always accelerate at the same rate. So mass does not matter. All objects will accelerate down that ramp at the same rate. So we're trying to solve for A, multiply both sides by g to get g out of the bottom. And we've got our equation. My acceleration down the ramp is simply g sine 25, which is 9.8 meters per second squared, sine 25 degrees, which gives me 4.1 meters per second squared. Less than gravity, which makes sense, right? The maximum answer would be 9.8 if he was going down a 90-degree incline.